The thing is that in the last class, we discussed about a few things about the logistic regression. Now, today we will discuss few things about the logistic regression in the theoretical section, and then we will move to the coding part. Now, in logistic regression, there is one parameter by which we can test the whether my model is accurate or not. And this accuracy, the measurement of my model, whether it is accurate or not, it is done by means of a matrix which is called a confusion matrix. Right. I had also told something about the confusion, just give the introduction in the last class, what is confusion matrix. But the thing is that today we will discuss details about the confusion matrix. Now, I'm sharing my window. Just a minute. Now, in the confusion matrix, the matrix, sorry, is it visible?
Yes, sir.
Okay. Just a minute. This is the matrix. I divided it into 4 square, and the left side is TP. The one of the right hand side is FP, then FN, then PN. Here, this one is positive. This is negative. This is again negative. And this is positive. So this is the figure of confusion matrix. Now, TP stands for true positive. If P stands for false positive. If N stands for false negative. And TN stands for true negative. Now this cross and this cross. This cross signifies the correct prediction. Correct predictions. And this cross signifies the wrong prediction. Wrong prediction in confusion matrix. So true positive and true negative signifies the correct prediction, and false negative and false positive signifies the wrong prediction. Now, what is true prediction? The true positive. The true positive means whatever we are predicting, the predicted value, it matches with the actual value. If the predicted value matches with the actual value, then it is called true positive. Right. So suppose there are two classes, 1 and 0. Class 1 is positive and class 0 is negative. So if we correctly classify one of them, then it will be a true positive. So if my predicted value matches with the actual value, then it is termed as true positive. In true negative, here also, when the predicted value matches with the actual value, that is, we in true positive, we predict 1 and my actual value is also 1, then it is true positive. In true negative, we predict 0 and it is actually 0, then it is true negative. So here also the predicted value matches with the actual value, right? So this is true negative. Now false positive, false negative, what we predict as 0, we predicted 0, but actually it is 1. So that is false negative, right? And in the false positive, we predict them as 1, but actually it is 0. That is false positive. So this prediction and the actual value. So predicted value is, I'm comparing the predict y pred with y test. My actual value is the test, right? So y test is the actual value and y pred is my predicted value. So if I, so again I'm repeating that when my predicted value is actually 1, and when my predicted value is 1 and the actual value is 1, it is true positive. When my predicted value is 0 and the actual value is also 0, then it is true negative. When my predicted value, when my predicted value is 0, my predicted value is 0, but the actual value is 1, but the actual value is 1, then it is termed as false negative. But when my predicted value is 1, when my predicted value is 1, but the actual value is 0, then it is false positive, right? So in the 4 quadrants, it is seen that when my predicted value is 1 and actual value is 1, then it is true positive. When my predicted value is 0 and actual value is 0, then it is true negative. When my predicted value is 0 but actual value is 1, then it is false negative. When my predicted value is 1 and actual value is 0, then it is false positive. Got it? Got it? Is it clear?
Yes, sir.
Yes, sir.
Now, there are certain parameters by which this prediction is measured, right? Now, these parameters are termed as precision, precision, number one. Number two is accuracy, accuracy. Number three is sensitivity, sensitivity, or termed as recall. Number 4 is specific. Now, these are the parameters by which the model is measured. The confusion matrix is measured and calculated. First, we will see the precision. Precision. Precision means that the percentage of true positive predicted, percentage of true positive predicted among all the positives predicted. That is precision. Percentage of true positive predicted amongst all the positives predicted. So this is represented mathematically as TP by TP plus FP into 100. So the percentage of the true positive, the percentage of the true positive predicted amongst all the positives predicted, that is termed as precision. That is defined by the precision, right? Understood what is precision?
Yes, sir.
Now, accuracy. The accuracy is defined as the percentage of true positive and true negative detected by the model in the entire data. Percentage of the true positive and true negative detected by the model in the entire data. So the percentage of true positive and the true negative detected by the model in the entire data, that is true positive, false positive, plus true negative plus false negative into 100. So this is accurate. Understood accuracy?
Yes, sir.
The next is we move to the sensitivity or recall. Sensitivity. It for every outcome, it it actually indicates how efficient the model is. That is for identifying each and every event, how efficient the model is, how efficiently the model works. That is defined by sensitivity. That is, sensitivity is a true positive rate, which is uh, defined as the percentage of the true positive predicted among actual positives. In the precision, we see that the percentage of true positives predicted amongst all the predicted positives. And the sensitivity says that the percentage of true positives predicted among all the actual positives. That is sensitivity. So I can write over here percentage of true positives predicted among all amongst the all actual positives. Right. So this is sensitivity. Right. So amongst the actual all the positives, amongst the actual all the positives, what is the true positives of the sensitivity? Right. So this is what the sensitivity. The next we move to the specificity. Have you understood the sensitivity?
Yes, sir.
Specificity. Specificity measures the percentage of true negative predicted among all the actual negatives. Percentage of true negative predicted among all predicted among the all actual negatives. That is specific. Right. Understood?
Yes, sir.
Now, another thing is AUC. This means the AUC stands for the area under the curve. It determines the curve with true positive rate and another curve which determines actual data points. So in the classification problem, there are two curves. The curve with a true positive rate, the curve with a true positive rate. Another curve is used to determine the distance between the two curves. So the more the difference between the two curves, more perfect is the classifier. So if this is a false positive rate and this is true positive, understood?
No, sir. Please explain it again.
Area under the curve. AUC stands for the area under the curve. We generally, these are basically the parameters by which the confusion matrix is measured. Now, in area under the curve, there are two curves. One is the predicted curve, another is the actual curve. The predicted curve, the curve with true positive, which determines the curve with the true positive rate, the curve with the true positive rate, and this is the another curve which is for the actual data points. So these are the predicted, I make a prediction in the prediction analysis with the help of this. This is the curve of my predicted curve and this is the actual curve. So if there is a difference between predicted curve and actual curve, the more the difference between the predicted curve and the actual curve, the more perfect the classifier is, and more perfectly the classifier can be able to establish model. Right. So this is the area under the curve. So more the distance between the actual data points and the predicted data points, the more the classifier is more perfect and more efficient. Right? Understood now?
Hello, sir.
Yes, sir.
Understood now?
Yes, sir.
Sir, actually, the residual that is actual and predicted should be low in order to have the better performance, right? I mean,
Yes,
then why if there is a larger distance, then why it is accurate?
this is the distance between the two curve. We are measuring the difference between the two curve, right?
Yes.
We are measuring the distance or the difference between the two curve. The more the distance, it is theoretically explained that the more the distance between the two curve, the more the perfect is the classifier.
Okay, sir.
Now these are the curved line without prediction, without the prediction. So this is false positive rate, and this is true positive. The here it is saying that if there is more the distance, the better is the classifier, because uh, the more the area is covering, and hence it is called the area under the curve. If the distance is very narrow, if this is an actual uh, this is the actual data points, and this is my predicted data value. If the distance between the actual and the predicted value is very narrow, it does not covers the lot of area. But if the distance between the actual and my predicted value, if the actual value, we are doing a linear logistic regression. So if the actual curve is this and my predicted curve is this, so it covers a lot of area. That is why it is called AUC, area under the curve. But if the actual value is this and my predicted value is this, it does not covers a lot of area. The more the area it covers the between the curve, the more accuracy the model is according to the theoretical part. That is why it is called area under the curve or AUC. right?
Yes, sir.
Now, another thing is called overfitting. Whenever we are training up the model, that is, whenever a model is learning, some unnecessary patterns or unnecessary patterns may be incorporated, and uh, that is called, these unnecessary patterns are basically nothing but the over, such as the, if I say in terms of signal, the noise or noise kind of data is entered, which is mixed up or using some circuitry mixture. The noisy signal is mixed with the actual signal and it creates a noise. So noise is basically an outlier, and with the help of a filtering method or with the help of filtering, we can eliminate the noise. So noise is basically an outlier. In that, similarly, in that in machine learning, there are some unnecessary pattern or unnecessary data may be incorporated, and these unnecessary data or the patterns which are incorporated, that is termed as overfitting. Right?
Yes.
You got it?
Yes, sir.
Overfitting is nothing but an outlier. Oh, now we will get the plan. And this is a step-by-step procedure for logistic regression. So in case of all the machine learning algorithms, we are importing the library. That is, we are importing the pandas, the PD, and NumPy array as there. So from the sklearn, we import preprocessing, and we have to show some graphical applications. That is why we are using matplotlib as pyplot. So we are we want to, so here the pandas is used for import pandas as PD, numpy as NP. From sklearn we can not, you just omit this statement and you can write import matplotlib.pyplot as PLD for the graphical application, and then you can give the font size as the 14, or then you can make it run. From sklearn linear model import, we are importing logistic regression, and again we are creating over here as a train test. We are splitting the model, and for Seaborn, if I want to see the graphical applications in machine learning can be implemented in two products, two libraries. One is for the matplotlib, another is Seaborn. So I did with matplotlib. I think this matplotlib is more comfortable to plot for graphical display than any other application. So for any other function. So that is why we are using matplotlib, not the Seaborn. We can use Seaborn, but matplotlib is very common rather than Seaborn. So we use SNS for Seaborn, as in matplotlib we are used as PLT. Similarly, in Seaborn, we are using an alias of SNS. Right. You have to explore some library, that is the Seaborn library, as in the SNS, and then we then again we will start to plot. We are setting the Seaborn test with the color white, and for white green in the color, obviously the color should be true. Now I want to do my own. Now I'm importing this. Now let us see about the suppose coding part. So I'm using this from sklearn from sklearn.linear model import logistic regression. And from I'm importing the logistic regression and then I'm splitting the logistic regression into train set and test set. So I use this. There is a CSV file of bank. The bank customer records file. We can also import this seaborn. So this is validation. Cross validation we will do later on. If I just copy the model. Now I have to, this is basically a bank data set. So the data set is not given. The data set is not given. There are input variables which are using in the data set. Right. The data set is basically converted into the CSV file. And here also use Dropona. Dropona means if there is null value, then the whole row will be dropped or lost or deleted. So if there is any null value, so the whole number will be dropped, lost or deleted. That is Dropona. So here we use the CSV file of the bank data set and we use if there are any duplicate values or null value. If there is a null value, then the whole row will be dropped. Now we are using shape. The shape is used to reshape the file. Is used to reshape the dimension of the file. That is why we are using shape. And after doing this, we are seeing this output. Now, what are the inputs which are taken? Firstly, the age, the job, which is the job title, the categorical admin, blue collar, entrepreneur, housemaid, management, retired, self-employed. So these are basically the job types. Narrative status, then these are the education, which is taken as an input variable. The professional post, and the default as a credit in the default want to be someone has forgotten to bring the line. So that is defined by this default as its credit card. Whether you have this credit card or not, that is defined by this default. The housing loan. So contact number, month, day of week, duration, campaign, and the number of days that are passed by the client by after the client is contacted with the previous campaign, the number of contacts performed before the campaign and for this client. So these are the basically the various fields which are called input field. There are input variables, and with this input variables, the corresponding bar plot, the corresponding just a minute. Hello. Hello. Not তখন বলে দিলেই হবে। তখন বলে দিলেই হবে। And with this, the customer job distribution, the narrative status distribution, these are the various bar charts which are drawn with the respect of the input data. Right? So this is heat map, the different combination or the different graphical combination which is used, and this heat map is used to when these things are used basically of comparing the two things, that is the area on the graph AUC. We can also analyze it with this heat map. Now, then we are again splitting the data set in two parts. One is training set and test set. And after that, we are creating a logistic regression. And the regression is after created. It is we are predicting the model and the confusion matrix. Right. From there, we measured the different parameters of precision, recall, F1 score, and the accuracy. Now, going. Just a minute. I get that data set or not? So is there any problem? We will do the coding on the next day.
Okay, sir.
Tomorrow
where,
we have class, sir.
sir, where the data set is available?
Uh, data set is available on this article, and after we have to download that particular data set from that particular article, and we have to convert it into CSV file, and then we are going to code.
Okay, sir.
I will show all these things in the next class. Right.
Okay.
Sir, tomorrow do we have class?
Yes, we can.
Okay, sir.
Okay, and on tomorrow we will start from 9.
Okay, sir.
Okay, sir.